Welcome to momedaram. In this video we will see vector class. Vector class is one of the implementation class for list interface. A vector stores elements similar to array list, but vector is synchronized. That means array list is similar to vector, but this vector is a synchronized one. That means this vector is thread safe. The underlying data structure is global array. That is, the vector class is implemented by using global array data structure, and this vector allows duplicate elements. Insertion order preserved. The order we inserted the elements, it will be stored in the same order. That is, insertion order preserved. Allows heterogeneous objects. This vector allows different type of objects it will allow. Null insertion is possible. By using vector class we can able to store null values also. Vector class internally implements serializable and clonable interfaces. As we know, all collection classes implements serializable and clonable interfaces. This vector class implements random access interface so that any random element we can access with the same speed. So this vector class implements random access. As we see in array list also implements this random access interface. So vector is implementing here list interface, random access interface, clonable interface and serializable interface. As we have seen the properties of vector class, right? All the properties are we are having exactly in the array list also. The main difference between vector and array list is only this vector is synchronized version, that is thread safe, and this vector is introduced in 1.0 version and the array list is introduced in 1.2 version. So every method present in vector is synchronized and hence vector is thread safe. Now we will see how many ways we can create this vector objects. Constructors of vector class provides many ways to create a vector object. So the first constructor is vector v is equals to new vector. What it will do? It will construct an empty vector so that its internal array has size 10. That means this vector object will be created with empty list. Empty means it will not have any elements and the default capacity will be 10. So if you see in this example, we have created vector v is equals to new vector and we are applying v dot size method and v dot capacity method. What this size method will talk? How many elements are there? Currently how many objects are there in the vector, it will show. This capacity method shows how many elements it can store. That will talk about this capacity. So if you see here, size is 0 and the capacity is 10. So by using this default constructor we can able to create the vector object and it has 0 elements and the capacity will be 10. So once the vector object reaches its max capacity, that means if we added 10 elements to the vector, after that if you try to add any another element, that time what will happen? A new vector object will be created with the new capacity of current capacity into 2 and objects will be shifted to the newly created vector object and so on. So if you see in this example, we have a vector object, it is of size 0 to 9, that is a 10, default size is 10. So we have inserted 10 elements in it, and if you try to insert 11th element, that time what will happen? A new vector object will be created with the current capacity is current capacity into 2. So here we have current capacity is 10, so 10 into 2 is 20. So if you see, the new object will be created with the size 20, I mean the capacity will be 20, and whatever the elements are there in the object, all the elements will be shifted to the newly created vector object, and the next element, whatever the element we are planning to add, right, that will be added at the end and this object v will be not points to the existing one, and it will start pointing to the newly created one, and whatever the existing object is there, right, it will be eligible for garbage collection. And if this, and we have added up to 20 elements, what will happen next when you try to add 21th element? Again new object will be created with the capacity is 20 into 2, that is 40. The process will continue. And if you see in this example, so we have created vector object and we are inserting the momedaram true a, false momedaram 123.12 null 123 bc. So if you see in this example, we have inserted string, boolean data, character, string, float, character we are inserting. So vector stores heterogeneous data, that is different type of data it is storing. Here null insertion also possible, and here it is allowing duplicates also. In this example we are trying to print the size and capacity. We have added 10 elements, right? So the size is 10 and the capacity is 10. So when you try to add 11th element, that is if you try to add 11th element, what is happening? The size will be 11 and the capacity is 20. So in this example we understand that when it reaches its max capacity, when you try to add another element, that time it will automatically increase the capacity of current capacity into 2. So the current capacity here is 10 and the newly created capacity is 10 into 2, that is 20. The next constructor is vector v is equals to new vector of int initial capacity. By using default constructor, we can able to create a vector object, empty vector object with initial capacity is 10. Once it reaches max capacity, new capacity will be incremented and elements can be added. Even if it is reaches its max capacity, again new object will be created. So if we are sure about how much capacity will be there, like how many elements we can able to store, that time we can use this constructor, so that many new objects creation won't be there. So this will help us to improve the little performance improvement also will be there. So by using this constructor, we can able to create an empty vector with the specified initial capacity. So if we create a constructor by using this, if we use like vector v is equals to new vector of 100, that time vector object will be created with a 0 size and capacity will be 100. And the next constructor is vector v is equals to new vector of int initial capacity comma incremental capacity. So if you see in this second constructor, if you use the second constructor and the capacity is 100, once it reaches max capacity, the new capacity will be created, that is 200. So in that situation, if we added only 2 or 3 elements, that time remaining 95 locations will become wasted. So in that situation, whatever the increment percentage you want, percentage means whatever increment you want, that much increment value we can able to provide by using this third constructor, that is vector v is equals to new vector of initial capacity comma capacity increment. So by using this constructor, we can able to construct an empty vector with the specified initial capacity, and capacity increment is whatever the value we are going to provide. And the next constructor is vector v is equals to new vector of collection. This constructor is used to create the equivalent constructor for the collection objects. So this creates a constructor vector containing the elements of the specified collection. By using this constructor, construct a vector containing the elements of the specified collection, whatever the collection elements we are going to have, right? By using that, we are going to create the equivalent for the that equivalent to that collection object we are going to create. So if you see in this example, we have here we used initial capacity constructor. So vector v is equals to new vector of initial capacity, we have used 100. So we have added up to 100 elements and we are printing the size and we are printing the capacity. If you see, the size is 100 and capacity is 100, and when you try to add another element, the size and capacity is incremented. The size incremented is 101 and the new capacity is 200, that is current capacity is 100 into 2 is 200. If you see in this example, we have created a constructor with the increment capacity comma capacity increment. So what we are doing, first we are adding 100 elements. The initial capacity is 100, we have added 100 elements and we printing this size and capacity. So the size is 100 and capacity is 100, and the next we added one element, so the size is become 101 and the new capacity is 105. Here 105, how it is become, the initial capacity plus whatever the increment value we have added, that 5 is 5 elements are added. If you see, by difference between these two constructors is, by this constructor whatever the value is there, right, the capacity will be double, but here in this case the capacity, the new capacity is whatever the value we have provided. And if you see in this next statement, we are adding 5 more elements, so the capacity reaches 105. And when you try to add a new element, so it is giving, and when you try to add new element, what it is giving, the capacity is, the size is 106 and the capacity is 110. Here in this situation, whenever it reaches max capacity, it is not doing the capacity into 2, it is just adding the current capacity plus whatever the value we have provided. So this is all like how we can able to create vector objects with different constructors. And if you see in this example, we have added a array list object, we have added some elements. In this example, what we are trying to do is, we are trying to see how many ways we can able to add the elements to the vector object. So if you see, we have v.add of object, v.add of index comma element, add all of whatever the collection object, and add all of the whatever the collection we are having at the specified index position, and we are using add element method. So if you want to add any element to the vector, these many methods are available. This add element method is applicable for vector class, it is applicable only for vector class. If you see here, add is there, here add element is there. This is legacy legacy class, right? Legacy means old class, right? 1.0 version. That is the reason the length of the names, method names are a little big. So here if v.add element is, this method is belongs to the vector class. In this example, if we see, if you want to remove any object from the vector object, these many methods are available. Remove of object, this method removes the object. If it is repeated for 2 or 3 times, that time first object occurrence it will be removed. Remove of index, it will remove the specified index value. Remove all of collection, so if you want to remove any collection of object, that time we will use this one. Remove element method, if you want to remove an element, by this method is a vector specific method, that is we remove element is there. By using this method, we can able to remove the object. Remove all of elements, this method also what it will do, it will remove all the elements. Like in the collection we are having clear method, right? This remove all elements will behave like a clear method. And if you want to remove an specific index one, like here we are having remove of index, we are having, right, remove of index. In the same way, remove element at index is there, right? These remove of index and remove element at like these two methods are like we can say both are behaves like same, it will do the same functionality. So if you want to remove an element in the specified index, that time we will use remove element at, this remove element at and remove all elements and remove element. These three methods are belongs to the vector class. You see in this example, we have added some elements to the vector object, and if you want to retrieve the data from vector object, we have these many methods, that is get method. If you want to get an object at the specified position, by using, we can able to use this get method. If you want to get the first element, that time we will use v dot first element method. V dot last element, if you want to retrieve the last element, that time we will use this v dot last element method. If you want to get the element at the specified position, that time we will use this element at method. If you see this first element, last element and element at, these three methods are belongs to the vector class. So here get of one and element at of index, these two methods are equivalent methods, so these two methods behave the same. And if you want to know the size of the vector, like how many elements are there, we will use a size method. And if you want to know the capacity of this vector, that is like how many elements it can store, that time we will use this capacity method. So in this video we have seen what is vector class and the properties of vector class, and how many ways we can create the, that is, constructors of vector object, and what are all the add methods are there, what are all the remove methods are there, and what are all the retrieval methods are there for vector object. This is all about this video. Hope you found this video helpful. Thanks for watching.